Welcome to lecture 24, unit 4. We are going to discuss about pre-treatment of steel and role of slag and steel making reactions, physical and chemical reactions. What is the steel produced by LD converter? How do you produce? What is the LD converter steel making design parameters, dimensions, and what are the raw materials are used to produce steel through LD converter steel making process, and why do you require pure oxygen and how do you produce it, and what is the source of oxygen, and what are the chemical reactions in LD, and thermodynamics of oxygen, sulfur, phosphorus, carbon removal will also be discussed, and slag metal reaction importance will be discussed, and modern development in LD converter steel making will be discussed here. First, let us know about pretreatment and role of slag. The pretreatment process objectives are to reduce the amount of sulfur and phosphorus content in liquid pig iron which was coming from blast furnace process. And what are the advantages by reducing the sulfur and phosphorus is you can recycle this particular slag to blast furnace to recover useful elements such as iron and manganese, but this sulfur and phosphorus are useful in few limited application. For example, excess sulfur is preferable for machining, for getting the good machinability. Excess phosphorus is preferred. It doesn't mean that excess phosphorus, limited phosphorus and limited sulfur is preferably useful for the phosphorus to increase the corrosion resistance. It is one of the example daily iron pillar. And coming to there is a possibility if you reduce these sulfur and phosphorus at repeat treatment stage, less slag will be formed and less lime will be required for steel making. You mean converting from iron to steel. And coming to what are the reagents used for pretreatment process are soda ash, Na2CO3. This Na2CO3 will react with carbon in molten pig iron, gives sodium as a form of gas and CO as a form of gas. It means carbon is reduced. Similarly, react with silicon in a liquid pig iron, gives rise this Na2 and SiO2 as a slag compound, and carbon remains in the liquid iron. And this also combined with combination of carbon and sulfur, it removes sulfur and it reduces the carbon also. And there is another reagent, combination of Na2CO3 and sodium sulfate. Usually at this temperature Na2CO3 dissociate into Na2O and CO2. This Na2O will mix with Na2SO4 and phosphorus in the liquid pig iron will be reacts and gives products such as P2O5 liquid form slag and Na2S liquid form slag and SO2 gas. It means sulfur is reduced to some extent and phosphorus is also reduced to some extent in pretreatment process by using these suitable reagents. Coming to the other reagent, combination of CaO and MgO, usually you use limestone in the case of these iron production and steel production as a flux. This limestone dissociate and gives rise CO2, remains CaO, and CaO and MgO mixture if we add, it reduces, it helps in sulfur in hot metal, but for these mixtures the nitrogen acts as a carrier gas. One need to note this point. There are few instruments used for pretreatment process in a way from the blast furnace to LD converter steel making. You use torpedo car for carrying the liquid pig iron. At this stage you carried out desulfurization and pretreatment or ladle. So either of the source you use to transport liquid pig iron to and LD converter steel making units. Within 15 to 20 minutes 70 to 75% sulfur reduces. One need to note this point. And there is another possibility to reduce phosphorus further. Add iron oxides to the liquid iron and add CaO, which is flux, or use sending the air blowing from the bottom or top or pure oxygen, and continuous removal of the slag helps to increase dephosphoration. You mean phosphorus content in the liquid pig iron itself. One need to know about the slag role also. What do you mean by slag? Gang plus flux. Gang is nothing but impurities associated with iron ore. In this particular situation, flux preferably CaO. When it combines, it combinedly gives slag. So as a film of slag you can remove out. There are many advantages with this slag. This particular slag acts as a separate layer or immiscible liquid between molten pig iron and steel, and top of the layer it forms as a sink for the impurities. For refining the steel, it forms a layer at top of the steel, hot metal. It prevents passage of nitrogen from the atmosphere. These gases usually exist in the atmosphere. It prevents. That is one of the advantage. The other thing is it absorbs oxide and sulfide inclusions and improves the mechanical properties or modify these particular inclusion shape and size. And it acts as a thermal barrier coating. For moving from the iron to steel, there may be temperature drop down. If this slag layer is immediately forming, it maintains the temperature or pouring temperature for LD converter steel making. And coming to the, it protects for reoxidation, entering oxygen from atmosphere to liquid iron again and again re-entering. It protects, it stops. And the other thing is it emulsifies between the carbon oxidation and hot metal such as liquid iron. It forms an interfacial layer. And what are the slag properties? Broadly it is divided into acid oxides, basic oxides. Acid oxide examples SiO2, P2O5, B2O3 and so on. And basic oxides example CaO and MgO. Neutral oxide example CaF2. You need to remember these things. First let us know these slag properties and physically and chemical properties. Physical properties is melting point is low compared to hot metal, density is low when you compare to the hot metal, viscosity is also low, surface tension is also low, and chemical properties basicity is minimum. That's why you will be getting the more metallic iron. And reactivity or activity coefficient of these particular things are mainly assumed as a unity, and oxidizing potentials, reducing potentials are maintained. Based on these things you can remove out whichever oxide is going in the first line, you can remove as a form of slag. About this slag properties, the one conclusion is that makes slag and slag makes steel based on the requirement which you want. This quotation, remember, you will be getting the more fundamental ideas. Is the pretreatment necessary after iron and steel making? Is it only necessary after iron making, or is it chosen after iron making or steel making also? Even after steel making also it is chosen for further reducing the phosphorus. One need to think about it. You ask yourself, you will be getting the more and more points. Read textbooks and ask yourself these questions. Does slag forms it itself, or do you intentionally make it? Do you mix it? Do you stir it to form steel, or automatically forms based on the thermodynamics and kinetics? Think about this particular situation.